It is 9:30 in the morning on August 1st, 2012. The New York Stock Exchange opens, just like it does every single day. Thousands of traders, brokers, and algorithms all spring to life at the same moment. Billions of dollars begin moving across fiber optic cables at the speed of light. One of the most sophisticated financial systems ever built, humming along exactly as designed. But somewhere inside the servers of Knight Capital Group, one of Wall Street's most powerful trading firms, something is wrong. Not obviously wrong. Not wrong in a way anyone can see yet. Just one server out of 8 running the wrong piece of code. Code that hadn't been used in nearly a decade. In the next 45 minutes, that one silent mistake will transform 212 customer orders into more than 4 million unintended orders, send nearly $7 billion worth of trades into the market, and completely destroy a company that took 17 years to build. No cyber attack, no market crash, no external attack, just one deployment, one misstep, and a system that worked exactly as programmed, even when what it was programmed to do was catastrophic. This is the story of Knight Capital Group, and this is the hidden layer. To understand what was lost that morning, you need to understand what Knight Capital actually was. By 2012, Knight had become a massive market maker. To see how that works, imagine you want to sell your car, but you don't have a buyer lined up. A car dealer steps in. They buy the car from you right now at a set price, and then they find a buyer later. They make a small profit on the difference. That's essentially what Knight did, but with stocks thousands of times per second. They continuously quoted prices, standing ready to buy from sellers and sell to buyers. In other words, they made sure people could trade immediately instead of waiting for someone on the other side. If you bought or sold a stock through a major online brokerage, there was a chance Knight Capital was involved in executing that trade behind the scenes. You never saw them, but they were the engine underneath a huge portion of everyday American investing. They handled approximately 10% of all U.S. equity trading volume. Think about that for a moment. 1 out of every 10 shares traded in the United States touch Knight systems. Every single trading day. On a normal day, Knight's systems processed millions of orders, making trading decisions in milliseconds across dozens of exchanges. It was the kind of scale that, only a few years earlier, would have seemed impossible. On the morning of August 1st, their market capitalization sat at around $1.4 billion, with over 1,400 employees. By the end of that day, 3/4 of that value would be gone. Every catastrophe has a before, a moment when a series of small, seemingly reasonable decisions set the stage for everything that follows. In early June 2012, the New York Stock Exchange announced it would launch a new program called the Retail Liquidity Program, or RLP, on August 1st. The program offered slightly better prices to retail investors by routing their orders through designated market makers. For firms like Knight, participating meant capturing more business. Not participating meant watching that business go to competitors. Knight made the call. They were in. The catch? The NYSE gave market makers just over 30 days to prepare. In a world of financial technology, that is an extremely tight deadline. It meant updating their core trade execution system, a piece of software called SMARS, the Smart Market Access Routing System. SMARS was built to handle large institutional orders by breaking them into thousands of smaller child orders and distributing them across multiple exchanges simultaneously to hunt for the best price. It did this reliably millions of times a day, handling an enormous volume of trades across multiple exchanges. And buried inside it, hidden in plain sight, was a ghost. A piece of code called PowerPeg. PowerPeg was a testing algorithm Knight had used years earlier to simulate extreme trading activity. It was specifically programmed to buy high and sell low. Not by accident, but by design. It was an intentional stress test tool created to see how Knight's risk management systems would respond when a trading algorithm started hemorrhaging money. It was a fire drill. It was never designed to run in the real world. Once it had served its purpose, it should have been deleted. But it wasn't. It just sat there, dormant, waiting, for 9 years. When the engineers began updating SMARS to support the new RLP program, they needed a way to turn the new functionality on, a digital configuration toggle, a switch inside the software. Rather than creating a brand new switch from scratch, the new functionality reused an existing flag inside the system. The problem was that this flag still had a completely different meaning in an older version of the software. Think of it like the electrical wiring in an old house. There's a switch on the wall that used to control a lamp that's no longer there. Rather than running new wire, an electrician decides to repurpose that switch to control a new ceiling fan. On 7 rooms in the house, this works perfectly. But in one room, the one that didn't get the renovation, the old wiring is still in place. When you flip that switch in that room, it doesn't turn on the ceiling fan. It turns on something else entirely. In software, we call this technical debt. The danger is when that technical debt is invisible. When nobody on the current team fully understands what the old code does, or what happens if it's ever triggered again. In Knight Capital's case, 9 years of invisible technical debt would come back to destroy them. Between July 27th and July 31st, Knight's operations team manually deployed the updated SMARS software across 8 production servers, 1 batch per day. Manually, as in a human being logging into each server one by one and copying files. In 2012, automated deployment pipelines were widely considered best practice for critical infrastructure. Think of an automated pipeline like a high-tech assembly line factory for code. Instead of a human manually dragging files, an automated system instantly takes over, runs tests, and safely copies the exact same files to all servers simultaneously. If even one server hiccups, the factory line immediately halts, sounds an alarm, and rolls everything back safely. Knight did not use this kind of system. They had no written procedures requiring a second technician to verify each server after deployment. One person, one server at a time. To make matters worse, their manual deployment script had its own bug. On July 27th, one of the 8 SMARS servers happened to be offline for routine maintenance. The deployment process failed to clearly indicate that one server had not been updated. The engineer running the deployment saw a completed job with no errors. Nobody checked the 8th server individually. When that server came back online, it was still running the old version of SMARS, the version with PowerPeg still buried inside it, and the old wiring still connected to that switch. And there was one final detail that turned this mistake into a catastrophe. A legacy bug had stripped PowerPeg of its tracking function. It had lost its off switch. It no longer had any mechanism to say the order is done. Stop sending more pieces of it. Server number 8 was a ticking time bomb. 8:01 a.m. Eastern Time. The market hasn't opened yet. Knight's internal systems began sending automated emails. 97 of them sent over the course of that pre-market window, all of them flagging an error described as PowerPeg disabled. These were not vague, ambiguous system messages. They named the algorithm, but they weren't routed to a monitored alert channel. They were sent to an email system that was not monitored effectively during that critical window. 97 warnings were completely unseen. 9:30 a.m. The market opens. There, engineers flip the switch to enable RLP trading. The signal goes out to all 8 servers simultaneously. 7 servers receive it and respond exactly as designed. The 8th server receives the exact same signal, but the old wiring wakes up PowerPeg instead. In high-frequency trading, the same mistake can become a market event before a human can even react. Within seconds, the 8th server begins firing child orders into the market. Because its off switch was broken, it just kept endlessly firing. Like a broken faucet that's been opened and has no handle close it. That morning, Knight's customers sent in just 212 legitimate parent orders. Routine trades. Instead, the rogue server began treating each of those 212 orders as an infinite task, firing thousands of child orders per second into a live market with real prices and real money. It was buying high and selling low, perfectly executing its old stress test programming. The machine just had no idea the money was real. Within 2 minutes of the opening bell, traders across New York noticed stocks lurching up and down within seconds. Something was systematically wrong with the market. Inside Knight's offices, the picture was chaotic and deeply confusing. Because SMARS distributed incoming orders evenly across all servers, the rogue behavior of server 8 was heavily intermixed with the correct behavior of the other 7 machines. The erroneous trades weren't coming from one obvious source. They were woven into the normal flow, making the signal nearly impossible to isolate. Meanwhile, the losses were accelerating at a terrifying speed. Knight was losing roughly $163,000 every single second, $10 million per minute. The firm had no automated circuit breaker to halt trading, no system-wide kill switch, and no predefined procedure for this scenario. They did not yet understand that one server was causing the problem. From their perspective, the safest assumption was that the latest deployment itself was broken. As the losses mounted, the senior engineers made a desperate choice: roll back the code. Take every server back to the last known working version of SMARS, stop the bleeding, and figure out the cause afterward. In standard software engineering, rolling back a problematic deployment is the safe and sensible move. Under these exact circumstances, it was the worst possible thing to do. The rollback meant replacing the software on the 7 healthy servers and replacing their software with the previous version. That previous version was the exact same codebase server 8 had been running all morning. The codebase were flipping the RLP switch activated PowerPeg. The moment the rollback completed, all 7 previously healthy servers suddenly adopted the broken configuration. In a matter of minutes, Knight went from 1 rogue server to 8. Instead of putting out the fire, they had handed the arsonist 7 more matches. The volume of erroneous trades exploding out of Knight's systems became staggering. For 37 different stocks, Knight's rogue trades accounted for more than 50% of the total market volume. As engineers worked to identify the root cause, they eventually shut down SMARS entirely. By roughly 45 minutes after the opening bell, the unintended trading had stopped. By then, the numbers were surreal. Over 4 million trades executed. The net loss? $440 million. In 45 minutes, Knight Capital had less than $365 million in cash on hand. They had lost more than their available capital cushion in less than an hour. Knight's stock price fell 75% over the next 2 days. The morning after the disaster, Knight's CEO, Thomas Joyce, appeared on CNBC and faced live questioning about what had happened. He publicly accepted responsibility, calling it our error. And on the trading floor that same afternoon, employees who had spent years building one of Wall Street's most powerful firms were quietly updating their resumes. Behind the scenes, the clock was ticking, louder than anyone realized. Knight needed hundreds of millions of dollars in emergency capital to satisfy its clearing obligations and reassure its clearing partners that it could continue operating. If it failed, it risked defaulting on its obligations, threatening not only the company, but potentially the wider market. 4 days after the disaster, they secured a painful $400 million rescue package. It kept the doors open, but the damage was done. Within months, Knight Capital was acquired, and the company that had once dominated electronic trading ceased to exist as an independent firm. Here's what most people get wrong when they talk about Knight Capital. They say it was a bug, one bad line of code, or an engineer who forgot to copy a file. But fixing a file copy mistake is easy. You had a checklist. What actually destroyed Knight Capital was a system of compounding organizational failures, each one invisible on its own, catastrophic in combination. Dead code, left as a liability. PowerPeg had been obsolete for 9 years. Dead code is not neutral. It is a loaded gun left in a drawer. A blind configuration switch, reusing a software toggle without tracing every consequence on a machine that didn't get the update. A silent failure mode, a deployment script that failed quietly instead of screaming when a connection dropped. No verification, no effective independent verification process on a system handling 10% of U.S. equity trading. Broken monitoring culture, 97 high-priority warning emails landing in an unmonitored inbox during critical pre-market hours. No kill switch, operating at machine speed with no single button or documented procedure to halt everything if the system went rogue. And finally, the rollback that made everything worse. Under extreme pressure, with incomplete information, a team of smart people reached for standard practice and caused total destruction. What should have been done instead? The answer is almost frustratingly simple. Stop the machine first. Ask questions second. Not a rollback, not live debugging. The correct move was a complete, immediate network containment, severing SMARS from the market entirely and checking the servers in silence. If they had a documented procedure that said, when in doubt, pull the plug, the damage could have been dramatically reduced. They didn't have that procedure. The machine won. What we often miss in technology is the hidden layer. The dead code nobody cleaned up. The switch nobody fully traced. The server nobody checked. The alert nobody was assigned to read. Knight Capital didn't fail because their engineers were incompetent. They failed because the processes, the safeguards, and the culture of verification were not built to handle what happens when something goes wrong. This isn't just a Wall Street tale. It's a warning that applies to any domain where complex systems operate faster than human beings can meaningfully intervene. And those systems are everywhere now. In hospitals making medication recommendations, in automated power grids, in aviation autopilots, and increasingly in artificial intelligence, where models are deployed into high-stakes environments with capabilities and failure modes that their creators are still working to fully understand. The speed and complexity are always increasing. The gap between what a system can do and what a human can monitor in real time is always widening. The question isn't whether complex systems will fail. They will. The question is whether the humans running them have done the hard, unglamorous work of building the safeguards, the kill switches, and the culture of caution needed to catch the failure before it becomes catastrophic. Knight Capital had the technology and the talent. What they didn't have was the organizational infrastructure to match the speed of the machine they built. That's the hidden layer, the gap between how fast a machine can fail and how fast the humans can respond. If you found this story interesting, or if you've seen these kinds of hidden failures in your own work, let me know in the comments. And if you want to uncover more hidden layers behind the technology we depend on every day, subscribe. See you next time.